Hi everyone. Today we are going to learn two very important concepts in Kubernetes, that is pods and services. These two components are the foundation of running application in Kubernetes. In a Kubernetes cluster, application run inside containers, and these containers are managed inside pods. So, but pods have a problem. Pods can change IP addresses whenever they start. So how do we access them reliably? So that is where the services comes in. So in today's agenda, we will learn about what is Kubernetes, what is pod, what are the pod YAML structure, and how we can create a pods, what is the services and type of services, and how you can create a services and expose our pods. And we will give you the demo of it. So I will give you a demo of it. Uh, let's get an idea of what is Kubernetes. So is an open source container orchestration platforms. It helps us to deploy your deploy your application in the form of containers. In a pods, we can have more than two containers as well for your deployment of your applications. So through your pods, you can scale your applications and manage your failures as well, and automate the deployments. Instead of running containers manually using Docker, Kubernetes manages everything automatically. Now let's understand what is a pod. So pod is the smallest deployable unit in Kubernetes. A contains multiple containers, contains more than one containers, and they share the same network through the container networking runtime interface, and they share the storage through, we all know that, through persistent volume claims, and you can decide the quality of state of your pods accordingly through request and memory allocation. So let's get started and learn about how we can start a cluster, and how we can deploy a pod through our and how we can deploy that pod through your inside your cluster, Kubernetes cluster, and expose them through the services. So let's get started and have an idea of it. So here we have an V cluster. We are creating a cluster through our V cluster. So we have used a cluster.yml file through which we can create a two node cluster. Here we can have an idea of it, that we are using for creating a cluster. We are using right now Docker, and for that we have kept a single node cluster where we have apart from a control plane, we are creating a one node cluster, that is your my worker. So let's start it, and through the CLI commands we will create a V cluster. So for that we will use this CLI commands as for that. So we are using right here that V cluster, V cluster, that we created my cluster, that is the name of the cluster, and the values we are using for it, that is your V cluster.yml file. So now we will enter that, and you will have your cluster being created now. So you can see here the whatever the required images that is required here, that will be getting fetched from the remote registries, and that cluster is getting created now. It is taking time, so need to wait for 1 to 3 minutes. Now the cluster is up and running, so you can see here that the cluster is running now. Let's have a whether the nodes are up or not. So let's get that one, kubectl get nodes, and you will see that the two node cluster has been created, and the version of your Kubernetes area one version 1.3.5, and the age of it is up at 32 seconds. So here the two cluster we have created now. The name of it, one of it is your my V clusters, and the second one is the my worker that we have we have the name that we have given under the vcluster.yml files. So now the two clusters are up now. So we will we but in a live production environment, we never schedules any pods on the on the master node or on the control plane. So let's check whether the clusters are control plane is tainted for scheduling your pods or not. So what tense is? Your tense is basically used to not scheduling your any nodes where you don't want to, or you don't want to schedule your pods on that class on that nodes. So that's why we will have a look into the we will describe first. Let us check whether the any tent or no scheduled has been assigned to that particular node or not. So if you will look here, I have used that kubectl describe node my cluster. So it describe the complete details of your node. That is one type of virtual machine. So it gives you the idea of it, what are the name of its cluster name, what role has been designed for this. That is a control plane and master node. Some labels have been predefined on it, and some annotations has been used here, so that is being predefined as well for that. Here you can see that there is an intent that is not specified here. So once you will so it's not been possible for us to be that whenever you create a run a pod, it might be scheduled on that tent on that on this node as well. So for that we need to keep it no scheduled on this particular node. So whenever you will run a pod, it will not be get scheduled on this node and this control node 10. So let's do that again. Let's do that for it. So now we will use a command for not scheduling any pod to be on this particular node. So we are using right now you as a kubectl 10 nodes my cluster key value, and that is being basically used for the toleration purpose, and that is being used now for as a no schedule. So the pod should not be getting scheduled on this node particular node. So the now node has been tented. Now it will be uh, the pod should not be scheduled on this node in future as well. So now if you will again run the command of kubectl describe node my cluster my v cluster, you should see here that the tent under the tent value pairs key value pair sections you will have a data like key values node schedule. So if in future you can use as customize that one for that it will be like some key value you can define under your toleration for the pod whenever you run create a pods for it, and you can under the container image below you can define your tolerations for any particular value like app is equal to frontend no schedule, so yeah, or something else. So it will not get scheduled on this, it should wait for it will look for that key value pairs whether you have defined it under the for the toleration, and it will if it will find the match it will get scheduled on that node as well. Or in if they you have not defined that toleration, then it will be not scheduled on that particular node. Or you can use a node affinity as well for if you like to schedule your pods on particular nodes, then you can use the node affinity rule or your node selectors. That also we can do that for. Now let's create a run a pod. One nginx pod we will run on particular node, and let's see whether it is running or not on particular nodes or not. So let's check it out. So here I am using running an image nginx image with the name of nginx, and we'll check whether that gets created or not. So it's not created. So let's check it out whether the so you can see it is gets it's running. So another command is if you look to check whether it is scheduled on which node, so you will have a look into it. So the nodes has been created with the name, so the pods has been created with the name nginx. It is up and running, so it now it is in the ready state. So and its status are running. There is no restart. If you have any liveness probe or something like you have a container that is running inside it. If there is any rescheduled or due to some there is any dependency on it, some another containers, so might be get readiness or liveness probe have you not defined that, so it will be not getting restarted for it due to some memory or CPU allocation. So so here it is right now, it not been restarted. The IPs that have been assigned for it for this pod are that 10.2.2.4.1.2. That is basically immutable. If the pod should, if I will delete this pods and re again create this pod again, then the IP should be changed. So basically if we are creating a deployment there, so pods IPs gets changed after whenever it gets restarted or if created again. So and next part is here, the node is where it has been scheduled on. So it's in the my worker node, not on the control plane node. That is we have the two nodes. If you will see, get nodes. So we have the two nodes, control plane and my worker node. So now it gets scheduled on my worker nodes because we have not entered this node, so it will get scheduled on these nodes. And further anything readiness grids and nominated nodes we have not been defined here, so it is working fine here. So let's now we will have to expose this pods through services so that we can access in the locally in through our local host. So so let's paste this command and run this one. So we have changed the name, sorry, that name has been changed. So now that services has been exposed, so now let's check the whether the services are also up and running. So now the pods has also been running and the services are also been exposed and with the node port type. So we have specifically some nodes, node related ports has been defined here as well, and the selector type is run and nginx. Now we will check again. Now we will have to port forward this the services to access from our local host, because we have not using any load balancers and we have not created any host entries. So we will use the port forward technique for accessing our mm, services through our local system Chrome browsers. So now we are port forwarding our services. So now it is up and running. So let's check it out in our browsers. This will be localhost. So it's running right up and so I think the services are running right now. So the sponsor services are running right now. So now exit and from it, and you will check if somehow your pods are not running, so you can check it out or debug your pods through your pod. So you can do that through describe pod and Nginx and the name of it, the pod, and you can see the pods details has been, you will find here the what are the name of it, what namespace has been defined, what's the service account if you have been defined or not. So all these things should be get you can acknowledge it through your kubectl describe pods. You can have that idea of whether the images are pulling right now or not, the container has been created or not. So these things should be get an idea of the all the events that is getting happen on this pod. So these things should be done here. So that's for today. You will have an idea of related to another video related to the Kubernetes concepts. Thank you everyone. Bye.